Your brain already makes its own version of THC. It's called an endocannabinoid system, and it's been quietly running in the background your whole life, regulating mood, memory, and appetite. THC just walks in and hijacks it. Here's exactly how. Scattered through your cerebral cortex, amygdala, and hippocampus are millions of CB1 receptors, docking stations built for your brain's own natural cannabinoid molecules. THC is shaped closely enough to your brain's natural cannabinoids that it fits directly into those same CB1 receptors, binding to cells throughout the brain and switching their normal activity on. Here's the key mechanism. Many of those CB1 receptors sit on neurons that release GABA, a chemical that normally acts like a brake, holding dopamine neurons in check. When THC activates CB1 receptors on those GABA neurons, it quiets them down. And with the brake reduced, dopamine neurons in the brain's reward circuit fire more freely. That extra dopamine flows into a region called the nucleus accumbens, part of the brain's core reward pathway, the same circuit involved in anything that feels pleasurable or rewarding. But CB1 receptors aren't just in reward circuits. They're dense in the hippocampus too, the brain region responsible for forming new memories. THC binding there directly interferes with how that region normally processes and encodes information. This is the well-documented reason short-term memory gets noticeably foggy while high, losing your train of thought mid-sentence, or forgetting why you walked into a room. The receptor activity in the hippocampus is directly responsible. CB1 receptors are also dense in the amygdala, the brain's emotional processing hub, which is part of why THC's effect on mood can swing so widely between calm relaxation and heightened anxiety, depending on the dose and the person. CB1 activation also reaches the striatum and cerebellum, regions responsible for coordinating movement, which is the receptor-level reason reaction time and coordination measurably slow down while high. With repeated exposure, the brain adapts. CB1 receptors become less responsive, and in some brain regions, their numbers decrease, which is the receptor-level reason regular users often report needing more to feel the same effect. None of this is random. Every part of the high, the calm, the memory fog, the shifted sense of time, the changes in mood, traces back to CB1 receptors sitting in specific, well-mapped regions of your brain, each one doing exactly what THC tells it to do. Now you know exactly what's happening in your brain, receptor by receptor. Subscribe for more Science Explained, and let me know in the comments what topic you want explained next.